Hi, everybody. My name is Maximilien. I'm the CEO of TelcoBridges, and welcome back to our podcast. I'm joined today once again by Luc Morissette, our VP of Client Technical Services. We're excited to record this second episode. The agenda for today is an exciting one. We're going to talk about APIs. What are they? What do they mean for the voice market? We're going to talk about services that we're seeing be used today. We're going to talk about services we see coming to market in the near term. And we're going to talk a little bit more about how ProSBC helps our customers enable these services in their voice networks. Luc, I'd like to just start with what is an API. Can you help our listeners kind of just level set?
Sure, absolutely. So we just have to take a step back, right? Because when programming started, things were all pre-configured. There were functions doing things, right? And each function was doing something else, right? At some point, or very early in the programming stages, people figured out that sending or dividing functions into different groups, and then sending a request with different parameters to do different things, right? So then this became an API. So you define parameters that you want to send to a function, and it returns you a result on this function. So this improved a lot capacity of these programming systems to be more flexible, divide functions that need to be done, and then go to the next level, right? Let's say this has evolved a lot, and recently there've been new APIs that have been created, like using a JSON string, using a RESTful API, which means you just send all the information you want in one string of data that you send to another system. Okay, so now it's not necessarily in the same system. It can be separate systems, it could be in the cloud, and then these data that are sent, which we call now APIs, are sent with all the data that you need to the different services. Services will do all kinds of different functions and will return you a result which you can use in your system.
Got it. Thanks for that. Yeah, APIs is definitely a buzzword today within the telecom space. I think every conference we attend or trade show we attend, there's a heavy use of the terms API. And I think it's also worth clarifying, we were talking about this offline, but effectively there are services or any kind of third-party product that is accessed via an API from an SBC, in our case, the ProSBC, right? So it's that the API enables the use of these other services within the ProSBC system.
Absolutely, and it's the strength of each service. So you can use the service which adapts more to your system, and then you can integrate that with APIs. So the service just needs to tell you which APIs they need, which parameters they need to take a decision or do a calculation or convert something. And then you just fill those parameters with the data you have, send that to that system. It will do processing as it needs to, and then return you the answer for this processing, right? Could be a calculation or anything.
Right. And we'll talk a little bit more about how they're applied in the ProSBC later, but ProSBC customers can use the ProSBC API to access a variety of third-party services. Is that right? And there's no real limit to how much it can be done, and et cetera.
We use different ways to send the API. So if it matches our ways of doing it, for sure we can. There's no limit on what we can use.
Thanks, Luc. That's helpful. And can you explain the benefit of REST APIs?
Yeah. So these APIs usually are used in the same programming languages, but now with REST APIs, you can send that to cross-platform. Right, so it can be a cloud service, can be another programming language. It doesn't matter. It just send the parameters, and the platform which does the function can be running anywhere. It could be in the cloud, and could be wherever it needs to be.
So now I'd love to talk about the services that we're seeing be put to use today via APIs by our customers. And the way I think about it is the SBC plays such an important role because it's managing the signaling packets and the media packets. And so because we have an API, you can effectively send those packets or information about those packets elsewhere and then receive something that you put back into the packets or receive information that allows you to make a decision on those packets. Is that the right kind of framework to think about how these third-party services are enabled?
Absolutely. And the way it's done is all the data passes through the system. So we have access to all the information of the who is calling and who is being called. And then these external services, they have special algorithms that will figure out if these are good calls, bad calls, or if you need to do other types of services, which we need to talk about, right?
Yeah. So the first one is something we've all heard about multiple times, is stir shaken. Is that right?
Correct. That's one we integrated quite some time ago. And when we receive the call, we get data from the incoming call. We send that out to the external servers, and they will go into their databases to figure out, if these the certificates for these numbers and are they valid. And then they will send us back a identity field, right, which is an encrypted information that is integrated into the call flow of the system and sent to another system. And the system terminating the call can then verify if this is a valid caller in the network.
Right. And for our viewers' benefit, for those that are less familiar, stir shaken is a framework kind of put in place by the regulators in the U.S., which just specify that the originating service provider needs to provide an attestation, A, B, or C, based on their level of confidence of where the call came from. And interestingly, that kind of framework is being applied internationally. So there's a number of other markets that are implementing stir shaken or stir shaken like frameworks. So stir shaken is a really important one. We're also seeing things like fraud prevention and blacklists becoming an interesting use case for APIs. Is that right?
Absolutely. So then when it's the same type of function, right? You receive the call, you get the data, and then you can use different ways of getting verifying if these numbers are good or not, right? So then you go in lists, you have suspicious numbers that are being used, you have just plainly fraud calls, and then these are flagged into the system, and then they are returned to the main call flow of your system, and then you can decide to should you inform the remote system that this is possibly a fraudulent call, or you can just drop the call if you really are sure that this is a bad call, right? So, but we use these external systems to evaluate the potential threat of these calls.
Right. The evolution of the fraud use case is helpful to think about, I find. A simple kind of blacklist database is a straightforward way to think about it, where the SBC will go check the blacklist database, come back with a decision or information to make the decision. I think this is where we're going to see evolution around applying AI and potentially trying to extract pattern recognition to figure out whether some of the traffic is driven by robocalls or some sort of scam. And so it feels like there's a lot of effort and innovation and resources being put behind that.
Yeah, because every time these services bring a new way to detect fraudulent calls, then these fraudulent systems, they change. And so you need to evolve this all the time. For example, blacklist is a good one, right? So you figure out that one of these numbers is not right. You should not use this number. It's not coming from the right originating network, stuff like that. So then you blacklist it. But then there could be mistakes that are done, right? So then you need to go back, unblacklist the number, and then make it valid again. So if you're more and more intelligent over time, then it becomes more useful.
Yeah, you get into all of this this conversation around false positives and false negatives, and which one's better or worse, and what are you willing to deal with within folks' network. Okay, so that's really helpful. And then another type of service enabled by APIs that we're seeing our customers use is toll-free databases, CNAM, local number portability. Can you talk a little bit about those and how those are applied?
Correct. So these in traditional networks, they were centralized databases in our networks, and they were queried for getting the name of the user, or if you call an 800 number, what's the real number you need to call, so you can query those databases. Today, these networks are slowly disappearing, so you need to have new ways of doing that. So by reaching out to systems that have access to those databases with APIs, of course, this is how you can reach those databases. And the example of local number portability, right? You need to know if this number has been ported, what's the new number to use. So these are similar services that are accessible, and now everything is being driven by APIs instead of older architectures.
Yeah. It always amazes me how much of software is really driven by interacting with and between databases, and that's exactly what we're able to do here, right? With the ProSBC is send to the database, receive from database, and that kind of enables a lot of logic within the call flows.
Absolutely. That's how it works.
Okay, great. Moving on to the next agenda topic, which is services enabled by APIs that we're seeing and expect to come to market kind of in the near term. I don't want to start talking about AI right away because I think that monopolizes the conversation a lot of time. Let's start with enterprise branded calling. And I really like this one because I think about it as just, it's the natural extension of Stir Shaken. It's almost like the industry realized that if you tell the terminating service provider that it's A-level attested, that the originating service provider knows the caller, the end user still doesn't know. The end user may still not recognize the number. The end user doesn't like picking up his phone if he doesn't know who's calling. And so the end user is still not picking up the phone, even if it's A-level attested. And so the solution was, of course, to move the attestation onto the device. And when you start doing that, you can put logos and you can put kind of call intent. And so I really, really like this one. I think it's going to hopefully add a lot of trust back into kind of the telco voice market, which is kind of our market and all of our customers' market. And so I'm really excited about enterprise branded calling. Is that how you see it?
Absolutely. So confidence, right? Confidence for answering the calls. But not only that, is that you can bring in additional information directly to the customer, right? When he sees what is going on. And now today, more and more, everything is getting connected. So you can get all this information right away. And confidence, yeah, I know who's calling. I know what is the type of call, and I'm okay to answer that and move on.
It's easy to imagine a future too where the caller will be asked to describe in 10 seconds the reason for their call, and then you'd be able to play that message on the device that is receiving the call. And so, we start to see a lot of enablement when it comes to voice as a product, which is pretty exciting. And then I want to add a little bit too. Based on the conversations we've been having, the reasons this is being talked about, but not a lot of people have seen it yet, is as we understand, there's still a lot to be done with the device manufacturers. So like Samsung and Apple software has to be compatible with this notion that there's more information getting pushed to the device. And so I think when we just think about all of the parties involved, the voice market and the SBC vendors are kind of ready, and then it's just making sure that the rest of the value chain is caught up and can manage it.
It's gonna cut up. It's gonna catch up.
So the next is AI, and we alluded to it when we talked about fraud. Maybe we can start with sentiment analysis, which is something that is well understood in the call center market. So that's where effectively AI or machine learning is being used to interpret the sentiment in the call, right? And that happens because the SBC's API is able to send the packets to this third-party database or software for interpretation. Is that right?
Yep, absolutely. And more than that, right? We've been working forever with customers that do these types of services. And sometimes just hearing the background noise of what's going on the call will tell you, okay, this is something wrong, right? Or it's not a valid call, or it should not be like this. And the tonality, there's all kinds of things that it can be analyzed in a call to figure out these types of calls. Are they valid? Are they make sense? And
Right. No, that's super interesting. And then on top of that, there's what's called AI call screening, which is more directly what we were talking about, which is, hey, can we identify some sort of robocall or fraud pattern in the way the originating number is behaving? Is that right?
yeah, well, yeah, that's what it is. So
We spoke to a customer together recently that was explaining that the straightforward pattern is just a lot of outbound calls to DIDs and then just adding a 1 at the end of all the numbers.
Something like that, yeah.
But then they were getting slightly more sophisticated where they'd add 10, right? And so then you can quickly imagine a variety of patterns that could emerge.
Yeah, that's what I was explaining earlier on, right? So these things evolve. You just need to follow the path. And if it's AI driven, I hope that it could predict those kinds of behaviors and just say, okay, no, this is the same thing. Let's just move on, right? So.
There were a couple of other interesting insights there too, right? So for this specific application, it feels like service providers are more willing to accept a false negative than false positives.
Well, it depends. It depends with what type of customer, right? So some cannot allow false positive. Some is the reverse. Each customer has their own preference on that. But as close as you are, if you are 100% sure, then for sure everybody will want it anyway, right? So.
Right. What are some other kind of API enabled services that that you've seen or you've been in conversations around?
Well, there's some So there's some routing functions, right? So advanced routing functions. So let's say on our devices we have some routing functions, but the customers may already have developed their own intelligence in routing. So then we can send data for routing information. That's one thing, but maybe we mentioned it before already, but it's adaptable to any type of service, right?
Right. So as these third-party vendors and third-party software companies come out with more innovation, all of that is enabled by being able to send signaling and media to this other place and then bring it back into the call path via the SBC.
Correct. Well, so usually it's only signaling because the media is processed after this part. Usually it's done at the beginning of the call. But there's also ways to do it in the middle of the call where if you figure out at some point this call doesn't make sense, you can drop it in the middle of the call as well. But usually it's only the signaling data that is being processed in those type of services.
Right. It's easy to imagine too how the bigger the network, the more important it is to have automation in these types of things. And so, Luc, what about latency? Do services enabled by APIs introduce latency problems when you're effectively sending packets or information on packets and waiting for a response?
So does it introduce latency? Yes. Does it introduce latency problems? No. Okay. So what you want in a call is that your end-to-end communication is as fast as possible, so you can reach your final caller, right? Who you want to call. And so when you introduce things in the middle, then you need to be quick in responding, right? So when you get data, you send that to an external server, you get the answer. It has to be done quickly. And all the services we have integrated are super fast. So it doesn't affect, it does add latency, but sub 100 millisecond latency in a call is almost not noticeable. So then you get the answer and you continue processing with the call. It is not a problem. Latency is not a problem.
Oh, that's interesting. Is it, so you mean if we're sending information and receiving information, because that pertains to logic on whether or not to connect the call, it doesn't really make a difference because then the call's connected and the media is the same, right? Is that what you're referring to?
Media, there will be no latency in the media once the communication is established. It's only before setting up the media, right? Of course, if there's a service that takes 10 seconds to process, then it will affect latency. But all the services we have integrated right now have not enough latency to make a difference in a regular.
I see. So there's a hardly noticeable slowdown in the time required to connect the call because there's a bunch of logic happening as to whether or not we should connect. And then once the call's connected, no difference in the way the media flows.
Exactly. And the services have to be optimized so that they respond in a timely fashion. But anyway, we put some timeouts. If ever we don't get answers, we just move on, right? So.
Right. Okay, that's helpful. So, Luc, I want to move on to the final topic of today's episode, which is how all of this pertains to ProSBC. And so I want to be very clear. All of the services that we mentioned today can be used in conjunction with ProSBC.
Correct. So we have different ways to use these APIs. The initial method we have used, we're using a SIP, just a SIP call. So inside the regular communication, we generate a new SIP call to get information from an external server. So we populate the SIP call with data sent to an external system. We get a SIP redirect with data that we integrate in the final call flow. Okay. But recently we have moved on to use HTTP queries instead. Okay, so real REST API queries. It makes it very easy to set up a connection. Okay, because what you do is you take all the parameters you need as the services need actually, and then you bring those parameters inside a specific request formatted a specific way, sending that out to an external system. The way we do it is we get into a special module of our ProSBC, and then we can configure what we need there. So the regular call flow is done with our regular processing, but then when we want to do an external query, we get to a separate system, separate function that formats the data, sends the data, and then when we receive the response, we can just extract that data and do whatever we want. For example, integrating the identity header in the SIP call, dropping a call, changing the CNAME value inside the call. So the caller name is now displayed correctly to the end user. So this is all done automatically with the system.
Right. And what you're referring to is the module in ProSBC that we refer to as scripts. Is that right?
Yeah, we call it routing scripts, but these could be plugins or stuff like that. So we're coming up with new names which are maybe more representative of what we're really doing. But since they are scripts and they are programmable, it can do anything.
Yeah, I think that part is important. So it's not rigid in so much as you have to specify, like there's a fixed set of parameters that you have to input. You can basically design all sorts of API calls to external services in addition to all kinds of manipulation around headers, numbers, etc., right?
Exactly. So when we receive a call in the system, we get hundreds of parameters available for sending to external services. But even more than that, we can add additional data coming in from the system. It could be which network we think we want to go. It could be which route we want to take. It could be this type of number should do something else. So it's very, very flexible. And then we send that out to these services.
Yeah, that's an important point. So there's 100 different parameters that you can use. And then there's effectively unlimited logic you can apply because you're just drafting or creating or editing the script right there in the module. And so there's basically no limit to what you can do with that data.
Yes. You are right. It's really fun.
So it sounds like ProSBC customers are going to be able to interact with all kinds of third-party services as they continue to innovate and get better, and there shouldn't be any issues integrating those into ProSBC.
And it actually happens every week. So we get new requests, new services, so we integrate that. Sometimes it's global services. Sometimes it's customer-specific services that we access.
And if customers need help creating those scripts or manipulating those call flows or interacting with those third-party services, they can reach out and your team helps them with that. Is that right?
Yes, correct. So most of the time, our team will do the work, but we have some customers that can do them themselves, and we've seen it a lot. But usually customers will concentrate on what they are strong is the services the services part, which is adjacent to our SBC functions.
Yeah, and something like Stir Shaken, we've of course helped many customers implement via the script and via the ability to send information to the third party, basically shaken provider.
Correct, but this is slightly different, meaning that these scripts are already designed, right? So we just need to activate those scripts. We don't need to recreate them every time. So we just activate the scripts in the systems, and it will do what it needs for Stir Shaken.
Perfect. Well, thanks so much for your time today, Luc. This was a very interesting conversation.
Thank you for having me.
Thanks, everyone.